Good morning, class. Here's College Algebra Practice Test Module 2, Chapters 3 and 4. Review, here's Chapter 4, Linear Functions. Okay, let's remind everybody about lines, slopes, and the interpretation of the slope. And so, by definition, if you happen to have a line, you pick up 2 points, rise y sub 2 minus y sub 1 over run x sub 2 minus x sub 1 is called the slope. Delta y over delta x, change in y, with change in x, rise over run, and that's the average rate of change of y with respect to x. So I'm reminding you of that. These are various lines, line with a positive slope, line with a negative slope, horizontal line with a zero slope, vertical line where the slope is undefined. So if you have a horizontal line, the equation is y equals b, m equals 0, and the y-intercept is at 0, b. If you have a vertical line, the equation is x equals a, m, the slope is undefined, and x-intercept takes place at a0. For a line, we have various formats. Standard form, ax plus by equals c. If you solve for y, becomes slope-intercept form, y equals mx plus b. And point slope y minus y1 equals m times x minus x sub 1. Two lines are considered parallel if they have equal slopes, different y-intercepts, perpendicular if their slopes are negative reciprocal of each other, or simply put, if you multiply, you get -1. So it's pretty straightforward. So those are various formats as far as the lines are concerned. Find the value of x if a linear function goes through the following points and has the following slope. The pairs are x comma 2, -4 comma 6. The slope is 3, and we want to find the missing x. Again, quick reminder of various types of lines: vertical versus horizontal, parallel lines versus perpendicular lines. This was discussed, just to remind you again, and then we are going to move on with this question, everybody. The slope is defined as rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 6 minus 2 over minus 4 minus x must be equal to the slope, which is 3. So we use this and this definition, and we write the following. Cross product, and this is 4. So 3 times minus 4 minus x equals 4 times 1 or 4. We distribute, we get -12 minus 3x on the left side. We move the -12 to the other side, make it positive. We end up with 12 plus 4 is 16. Divide by -3, and x is -16 thirds. Consider the scenario: a town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town population P as a function of year T, where T is the number of years since the model began. So in essence, we are using y equals mx plus b. That's the concept, everybody. P of t is the population as a function of t. The constant rate of growth is given as m equals 2,500 per year. The initial value, the initial population is 75,000, which is b. When we have the initial value, that is the y-intercept. In this case, becomes the p-intercepts because we're going to write p. And so the linear function, okay, y equals mx plus b, and we are going to use a p equals mt plus b. Y, the independent variable. So let's just write this. Normally we have x comma y. Now we are going to have t comma p. That's why we have this. So therefore p as a function of a t is 2,500 t plus 75,000. What will the population be 10 years from the beginning? Replace the 10, t with 10. So t is replaced with 10. This is 25K or 25,000. Plus 75K is 100K or is 100,000. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes will cost $71.50. 720 minutes will cost $118. Express the cost C as a linear function of the monthly minutes used, X. Minutes, comma, cost. That's X, comma, C. Okay, minutes is the independent variable because C is a function of X. And capital C is the dependent variable. The cost depends on the number of minutes used. So it's pretty straightforward. So we are going to write this X comma C, 410 minutes, 7150, that would be the pair. And this one would be 720, 118, the second pair. So the two pairs come from these two, X comma C. We know the slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But instead of y, we are using c. So we are going to write m is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is what we use in general. For this case, c sub 2 minus c sub 1 over x sub 2 minus x sub 1. Rise over run. The run uses the same variables, but the rise from y we go to c. So 118 minus 7150 over 720 minus 410. The numerator is 46.5. The denominator is 310. Becomes 3 over 20 or 0.15. Y minus y1 equals m times x minus x sub 1. And of course, remember, instead of y, you're using c. So c minus c sub 1 equals m times x minus x sub 1. You can use any of them. For example, c minus 118 is m 3 over 20 or 0.15 x minus x sub 1 x minus 7. So use this pair. So you simplify. It's pretty straightforward. You just keep this and then multiply this one, you get 3 over 20 or 0.15x, and you multiply these two, you get 108, so minus, because 720 is divisible by 2. You move the negative 118 make it positive on the right, you get plus 10. So the cost becomes 3 over 20 times x, or 0.15x plus 10. What is the cost using 687 minutes per month? So if we use 687 minutes, we replace a x with 687. We put it into a calculator. Can be done by hand too. And we end up with $113.05. In general, when it comes to money, when we do the rounding, we go with 2 decimals. That means if there are more decimals, the third one gives you a decision about the second. Okay, so that's how you do that. All right. So now you want to interpret the slope and the c-intercept. The y-intercept, we are going to call it the c-intercept now, represents the fixed monthly cost or the flat fee charged by company. So when we go back here, they charge $10 per month. The slope, which is 3/20 or 0.15. The slope represents the change in cost per minute of call for the amount of $0.15 or 15 cents per minute, meaning any additional minute will cost us 15 cents. So for example, 10 minutes, we are going to add $1.5 to this fixed cost. That's the idea. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. You want to include proper units. Even if they don't mention it, you always should do so. How tall is the sunflower 8 weeks after planting? So simply put, you plug in, everybody. F of 8, which means 6 times 8 minus 1/4 8 squared. And can be done by hand. So 48 minus 1/4 of 64, which is 16. 48 minus 16 is 32. The units, inches. Always proper units. Find the average rate of growth from the end of week 6 to the end of week 12, rise over run. Delta y over delta x, or f of x up 2 minus f of x of 1 over x up 2 minus x of 1. In this question, f of 12 minus f of 6 over 12 minus 6. So bottom is 12 minus 6 or 6. The top, 6 times 12 minus 1/4 of 12 squared minus 6 times 6 minus 1/4 of 6 squared. This is 72. If this is 1, $144, 1/4 of it is 36. This is 36. This is also 36. 1/4 of it is 9. So this is 72 minus 36. This is minus 36 minus 9. When you apply the negative here, everybody, this becomes negative, this becomes positive. These two cancel out these two. So you get 9/6, or 3/2 units of the numerator over the units of the denominator, inches per week. The numerator is this function, okay, in inches, and the denominator, weeks. So 3/2 of an inch per week. Recall, we've done this from module 1. A fitness club charges $20 as a monthly access fee and $2 per day of use. Express the monthly cost in terms of daily usage. Let X be number of days that we're going to use. So the cost will follow y equals mx plus b. This is your m. The slope represents the change in cost per day in this case. Per day in this case. The y-intercept, or in this case, the c-intercept, is the fixed monthly cost. So this is the fixed cost. So c of x is 2x plus 1. What will the monthly cost be if the club is used 15 days this month? Just plug in x equals 15. There's the and 20. It'll cost $50. A city's population in the year x equals 1998 was y equals 3,231,800. In 1963, it was 3,216,050. Compute the slope of the population growth or decline and choose the most accurate statement from the following. So First and foremost, we go with x comma y as the independent variable and a dependent variable, where x represents the time, okay, and y represents the population. So that's the first thing we should notice. So 2 points, x comma y. This is one of them, 1998, 3,231,800, and 1963, 3,216,050. So those are the two pairs, everybody. I'm going to calculate the slope. Rise over run. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So either subtract this one from this one or this one from this one, makes no difference as long as you follow the order. So since this is larger, I'm going to say this number minus this number, and then this number minus this number. It makes no difference, understand that. So with that being the case, 3,231,800 minus 3,216,050, that results in 15,750. 1998 minus 63 becomes 35, and it's 450. Now, the most accurate statement, there are some statements, this is the one. Please understand this is positive. Therefore, the population is increasing at the rate of 450 people per year. Unit of the numerator over the units of the denominator. Units of the numerator is the population. Units of the denominator is year. So 450 people per year. That's how you figure out the units. Also, let me remind you of this type of function. Find the absolute max and the absolute minimum if they exist. Some functions, they don't have absolute max. So notice the concept of absolute refers to the point where there is no other point having a larger y coordinate. This one is at top of the function. So the absolute maximum has the y coordinate of 6. You say, so absolute max is equal to 6 at this pair. Absolute max equals 6 at the pair 3, 6. What about absolute mean? This point, there is no other point that has a smaller y coordinate. And please understand that means a solid point. That means the endpoint is included. And by the way, endpoints can only be absolute. And so absolute minimum is equal to the y coordinate 1 at 0, 1. This is considered local max, which becomes an absolute max as well. This is local mean. What about this case? As you can see, this is the point with the largest y coordinate. So absolute maximum becomes 3 at this pair. Absolute maximum becomes 3 at pair 5, 3. But what about the absolute minimum? If there was a solid point here, you would say this is equal to 1 at 3, 1. But there is a hole, there is no absolute minimum. There's no absolute minimum because there is a hole here. The function is not defined at that. It's discontinuous. What about this function? The largest y coordinate as you look at this graph is this one. Therefore, this is the location of an absolute max, means absolute maximum is equal 4. When we say mean or max, we are referring to the y coordinate. So absolute max equals 4. At what pair? 5, comma 4. What about absolute minimum? I hope you recognize this as if you continue indefinitely, as a horizontal line with the same way y coordinate. So from here to here, they have the same y coordinate. So absolute minimum equals 1, but in the interval of 1 to 2. Absolute minimum equals 1 in this interval of from 1 to 2.